Guys, welcome to another video on Mechanics M1, and in this one we'll be looking at dynamics of a particle moving straight line, but in particular an example I picked up from the Pearson Mechanics M1 book, example 16 on page 63. Here we're dealing with a typical rough plane that's inclined, and I just want to break down every single possibility of these kind of questions. Okay, so this is just going to be a walkthrough on how to really understand, because these are questions which involve everything you've learned up to this stage. So without further ado, let's go. So suppose we had two blocks, one that was 5 kg, which is 5g, and other one which was 10 kg, which is now 10g. We also know that because the system is released on rest, the pulley, which is here, has some sort of light inextensible string, which implies that the tension should always be away from the particle, so it's going towards the pulley. So this is just a common fact. We also know that due to acceleration, the system will move up the plane. Why? Because this is heavier. This is twice the weight of this one, so it's most likely that this will go, as this one goes down, this will climb up. So as it goes down, we can give this an acceleration of, say, a, and of course this is also going upwards. Give this an acceleration of a. Now, considering the plane itself, if this is moving on a rough plane, we know that there's friction coming away from it, so we can give this friction of F. And it's always perpendicular to the plane, which is R. Now, a key thing to note is that the coefficient of friction here is given to be 0.2. We also know that the maximum friction at limiting equilibrium, F would equal mu times R, which is 0.2 R. And we also know that the angle is represented as tan alpha equals 3/4. Now, the easy way to do this without actually solving alpha is to consider a triangle, okay, with alpha here. Using trigonometry, we know this implies opposite over adjacent. So we know opposite here is 3 and the adjacent here is 4. Using Pythagoras theorem, we can do 3 squared plus 4 squared is altogether 25. Square root 25 will give us 5. So to find out the other values of trig, for example, cos alpha, without actually plugging in alpha, I would use this triangle because it gives you exact values, which is what the examiner wants. Cos alpha is simply adjacent over hypotenuse. So the adjacent here is 4 over hypotenuse 5. So 4 over 5. Same thing for sine alpha. Sine alpha is opposite of adjacent. So opposite is 3 and the hypotenuse is 5. Okay, dead easy. So the preliminaries are done. Now let us resolve the system. So the first thing you want to do is to divide this system into two parts. Firstly, that involves two different particles. Okay, we've got one here, one here. Let's work with the right side of the equation here. So we're going to call this the right hand side. This one is the left hand side. Okay, so from the right hand side, what do we have? We know that, let's resolve upwards. So we know we got t, resolving upwards, we have t minus 10g equals, and because acceleration is going down, it'll be negative. So it'll be negative, and using ma, mass is 10, it'll be negative 10a. So then this can be rewritten, plusing 10g across. We can have 10 tension equals, and factorizing 10, g minus a. Okay, I think this is quite clear. Plus you get 10g, take away 10a, factorizing 10, you get g minus a. Now that's literally all we can do here. So now we move to the left hand side of the equation. Here I recommend you work towards the direction of the acceleration, which is this way. So working towards direction of acceleration, we're going to consider t as the main positive. So it'll be t, and then we look back, we've got minus f. We also need to consider that this angle is bent. So remember, this is now the axis, yeah? So from here to here, we know that the angle is alpha. So we're going to have 5g minus 5g cos alpha, which we know the value cos alpha is here. And all of this, I think that's all the forces, should equal to, and because it's opposite acceleration again, no, because we're going direct acceleration, it's going to be equals 5a, mass times acceleration. So quite straightforward. Again, knowing, and then now let's do it other one. So we're resolving towards the perpendicular value of the plane, which is towards r, we're going to have r. And because t and f are perpendicular to this, we don't count them. We count this one, which is the other angle, which is also, okay, so this one should be 90 minus alpha, my bad. So this is 90 minus alpha. So this is going to be, hold up, Okay, so just quickly correcting this. 90 minus alpha equals 5a. Okay, now here, going back to what I said, so this one should be alpha. Yep, makes perfect sense. This is always equal to that. So we're going to have r minus 5g cos alpha. And this one, of course, equals 0. Quick thing to note, cos 90 minus alpha is actually identical to sine alpha. And this, in turn, is equal to 3/5. Okay, so all of this equals 3/5. So let's find the value of r. So this means that r equals 5g cos alpha, which we know is 5g times 4/5. Putting this in a calculator, it should give us, well, keeping the g's in terms, we should have 4g. Okay, so let's assume r is 4g now. I'm going to just put this up here. R equals 4g. That means, what's the f going to be? F is going to be 0.2 times r. So f equals 0.2 times 4g and should give us 4/5 g. Okay, good. So let me rub out this last line of equation because we don't actually need it. Now the key idea is that because we need to we need to substitute everything we have into the big equation to eliminate all these nonsense terms like f and t and keep in terms of a or g. Okay, so because g is a value, we just want everything in a single term. So replacing the value t here with 10g minus a, so we're going to have 10g minus a, minus, and replacing f with 4/5g, minus, and then simplifying this one, equal 5g cos 90 minus alpha. We said, we clarified this sine alpha. So we're going to have 5 times 3/5, which is 3g, equals 5a. And that's it. Now just a case of expanding and simplifying. So expanding this one, you're going to get 10g minus 10a minus 4/5 g minus 3g equals 5a. Collecting terms, so adding up all the a, so plusing 10a across, we're going to get 15a. Summing up the g's, we've got 10g take away 4/5 g take away 3g should give us 6.2g. And that's it, guys. Now all you do is divide 15 across, so 6.2g over 15 should give us an acceleration of a equals, well, there's two ways you can write. You can write the exact form, which is 1519 over this, which I bet you won't. Or you can just say 4.05 meters per second. And that's it, guys. And of course, if you want to calculate tension, you pop this value here. So T would equal 10 times whatever G minus A is. So putting this quickly should give us a tension value of 57 point, let's round it up, 5 newtons. And that's all, guys. Hope this helps, and let me know if you need any other problems or any other advice. And that's it, guys. Yeah, so the main idea is to always consider the steps and to always work out the bigger picture. My advice is always simplify as much as you can. Look at the small equation, simplify it as much as possible, and then substitute all your terms like t into here, f back in here, and solve for, in terms of a, and you got it. Okay, a few steps is literally baby steps, and you gotta be very careful. Your algebra's gotta be off the mark, spot on. But yeah, anyway, I think you got this, yeah? So ciao now, and we shall speak soon. Bye bye.